The important part of the second section in trigonometry is the definition of the 6 basic trig functions. We're going to do a little bit of review about vertex, initial, and terminal sides of an angle. You've seen some of that before. We're going to learn 6 new functions that are used in trigonometry, and we're going to use those 6 functions at 5 different spots on what's called a unit circle. We'll do a little bit of Pythagorean theorem review, and then we'll learn how to do those 6 trigonomic functions on the calculator. So the first thing we need to do is learn 6 basic definitions. Cosine, sine, tangent, secant, cosecant, and cotangent are all functions. They take an input and produce an output. The input for each of those is going to be an angle, just like our Greek letter theta right here, and each of those produces a different output. If I take any angle and plug that into the cosine function, I will get as an output the x-coordinate of that angle on a unit circle. If I take an angle and plug it into the sine function, I will get as an output the y-coordinate, and then the other 4 are either ratios or reciprocals of the first 2. So as an example, if I have any kind of a point sitting in the unit circle, and if I travel a certain angle to get to that point sitting in a unit circle, the x-coordinate is when I plug in the angle to the cosine function, and the y-coordinate is when I plug that angle into the sine function. So along our unit circle, centered at 0, 0 with a radius of 1, there are going to be initially 5 points that we're concerned with. And 2 of the points overlap, so we're going to be right back to where we started from. We already know one of these points. If I were to travel 180 degrees from the initial side and get a terminal side over here, that's the same thing as pi radians. So we know that pi radians is the same thing as 180 degrees. On a unit circle centered at 0, 0, this coordinate has ordered pair -1, 0. And I now know that the cosine of 180 degrees is -1. When I plug an angle into the cosine function, I get the x-coordinate out. I know that the sine of 180 degrees is 0 because if I plug an angle into the sine function, I get the y-coordinate. We're going to do the same thing for the other 3 points. If 180 degrees is pi radians, then 90 degrees is going to be pi over 2 radians. So if my initial side is right here, my terminal side is right there, or the y-axis, I have pi over 2 radians, which is the same thing as 90 degrees. The ordered pair at this location is 0 in the x direction, 1 in the y direction, which gives me the 2 basic trig functions of cosine of 90 degrees is 0, cosine of pi over 2, which is 90 degrees in radians, is also 0, etc., etc. The third angle down here, well, if 90 degrees is pi over 2 and 180 degrees is pi, then 270 degrees is going to be 3 pi over 2. If I start with an initial side here and put my terminal side all the way over here, the angle that I've just traveled is 270 degrees, which in radians is the same thing as 3 pi over 2. And I know that this ordered pair is 0 in the x direction and -1 in the y direction. And again, if I were to ask for something like the sine of 270 degrees, that would produce -1, or the sine of 3 pi over 2 radians is -1. The final spot has 2 names. It's both 0 degrees, 0 radians, or if I travel all the way around the circle, 360 degrees, or 2 pi radians. The ordered pair for this point is 1, 0. And so again, I could do sine and cosine definitions for those inputs. So those are the basic values. To do some examples, you'll eventually get these memorized to the point where you can do them very quickly. But if I asked for the cosine of pi over 2, if I remember that pi over 2 is 90 degrees, and if I remember that the ordered pair at 90 degrees is 0, 1, I know that the cosine is the x-coordinate, which is 0. If I ask for the sine of -pi over 2, I'm going to start at the same initial side, but instead of going up first, I'm going to go down first. So instead of going 90 degrees traveling through quadrant 1, I'm going to go 90 degrees traveling through quadrant 4. This -pi over 2 puts me at the same location as 3 pi over 2 radians, which is the same thing as 270 degrees. In any case, no matter what I call the angle, the ordered pair for this point here is 0, -1. And since I want the sine or the y-coordinate, I know that this is -1. Tangent is defined as y over x. So again, since I'm looking at pi over 2, which is 90 degrees, y over x is 1 over 0, which produces an undefined quantity. So sometimes inputs into trig functions produce undefined outputs. Cotangent of negative pi over 2, well, from the other screen, the definition of cotangent is x over y. Negative pi over 2 is this diagram again, which puts me with an ordered pair of 0, -1. X over y this time is 0 over -1, which can be evaluated as 0. Secant pi over 2, again, same location, 90 degrees. Secant is defined as 1 over x. 1 over 0 does not exist, so here's another example of an undefined quantity. And the last one, cosecant of -7 pi over 2. Well, 7 pi over 2 wasn't on one of the diagrams that we looked at a minute ago. It's not anywhere on here, so I need to do a little bit of work. -7 pi over 2 is the same thing as -3.5 pi. Every time I do one trip around the circle, it's 2 pi. So if I go -3.5 pi, I'm going around the circle one full revolution backwards, and that takes care of 2 pi. So once I've traveled 2 pi, I still need to go 1.5 pi, still in the backwards direction. 1.5 pi is the same thing as what happened down here. 1.5 pi is 3 pi over 2. So I'm going to go 270 degrees, but backwards from this spot here. So 270 degrees puts me right here. So -3 pi over 2, sorry, -3.5 pi, or -7 pi over 2, is the same thing as finding the cosecant of pi over 2. That's a little bit confusing, so you might want to think about that again. -3.5 pi, the first 2 pi is taken care of by doing one lap around the circle backwards. That's 2 pi. I've still got 1.5 pi to go. 180 degrees is 1 pi. 1/2 pi leaves me right here. That's the same thing as had I just traveled 90 degrees in the positive direction. So the cosecant of pi over 2 really means I need to find 1 over y for the ordered pair at 90 degrees. At 90 degrees, the ordered pair is 0, 1. So I need 1 over 1, which is 1. You'll get very quick at these if you practice them over and over and over again. The next example says, here's an ordered pair, and do 3 things to it. First, verify that P is on the unit circle. So P is this point. It has ordered pair, -1/2, -√3 over 2, and the way that we verify that it's on the unit circle is x squared plus y squared must equal 1. That's the equation of the circle. Circle centered at 0, 0 with a radius of 1 has this format. So to do the verification, I'm going to take -1/2 square it, add -√3 over 2 square it, and hope that it equals 1. -1/2 squared is a positive 1/4. Negative squared is positive. √3 squared is 3, and 2 squared is 4. 1/4 plus 3/4 is 1. It's verified. So that point P is indeed on the unit circle. Find the 6 trig functions at theta. Well, the 6 trig functions are all based on the x or y, or a combination of the x, y coordinates of the point P. So off to the side, I can start defining my 6 trig functions by saying cosine of theta is the x coordinate, which is -1/2. Sine of theta is the y coordinate, which is -√3 over 2. Tangent of theta is y over x, so I need to take -√3 over 2 and divide -1/2. Well, dividing means take the second fraction and flip it. Negative divided by negative is positive. √3 over 2 times 2 over 1 becomes √3. The other 3 functions are reciprocals of these 3, so the reciprocal of cosine is secant theta, that's 1 over x, and that's going to equal the reciprocal of this negative 1/2, which is negative 2. Cosecant theta is the reciprocal of sine, which is 1 over y. The reciprocal of this is negative 2 over root 3. In most cases, the square roots are going to be rationalized. In other words, you can't have a square root in the bottom. So if I were to multiply both of these by root 3 over root 3, I'm going to get negative 2 root 3 over 3. And then the last one, cotangent of theta, is the reciprocal of tangent. So I'm going to have x over y. I'm not going to redo all my division. I can just take my answer from here and find the reciprocal. So if tangent was root 3, I'm going to say that cotangent is 1 over root 3. And again, that needs to be rationalized by doing root 3 over root 3. You get root 3 over 3. So those are the 6 trig functions. Once you have an ordered pair, getting those 3 isn't a whole lot of work. So we've finished question 2. And then now question 3 says compare those 6 answers to the 6 trig functions at B. And that sounds like a lot of work because now I've got a new angle. But if we look at our diagram, theta has an initial to terminal that puts us in quadrant 3. Beta is the exact same thing but going in a different direction. So despite the fact the angles are much different, theta is a very large positive angle and beta is not quite of a large negative angle, I wind up at the exact same point. So the 6 trig functions at beta are the exact same thing as the 6 trig functions for theta. So the answer to 3 is exactly the same as the answer to 2. The last thing asks you to do some comparisons between sines and cosines using radians. Here is a circle with radian angles measured out. In other words, the initial side to this point here gives us an angle of 1 radian. The initial side to that point here gives us an angle of 2 radians, and we're supposed to compare these. Using trig definitions, we know that sine is the y-coordinate. So if I want to compare the sine of 3 to the sine of 1, I need to find these points on the unit circle and look at their y values. Which is larger, the y-coordinate at this point or the y-coordinate at that point? Well, I'm pretty sure that the y-coordinate for 1 radian is larger than the y-coordinate for 3 radians, so I'm going to say that one is larger. The next one involves cosine, so I'm going to again use 1 and this time 2. In order to get to 1, I would have to travel this distance in the x direction, and in order to get to 2, I would have to travel this distance in the x direction. Well, since this distance is negative, my guess, or my answer, is that the cosine of 1, the x-coordinate for 1, is larger than the x-coordinate for 2. So I'm going to pick this one. The last example is a little bit more challenging. In order to figure out which is larger between tangent 1 or tangent 4, I need to compare the x-coordinates and the y-coordinates. So here's 1 and here's 4. And tangent, which is y over x, can also be thought of as a slope. So to help me out a little bit, I'm going to draw on a 45-degree line, which is a line that has a slope of 1. So if I can very roughly get a 45-degree line, this is y over x equal to 1. That helps a little bit because now if I go from the origin to 1 radian, I can see that the slope of that line is a little bit more than 1. If I were to draw on this line here, this slope is a little bit more than 1. So I know that the tangent of 1 is greater than 1. Tangent of 4 also seems to be greater than 1, because if I were to draw a line again through 0, 0, it looks like it's very close. So I know that this one is also 1. My best guess for how to answer this is to figure out which one has a larger slope. So if I were to try and, let's get rid of those markings for a second. If I was to try and figure out which has a larger slope, I'm going to do the old change in y over change in x compared to change in y over change in x. And my guess, as an initial guess, is that this one has a slightly larger y value and therefore a larger slope. So tangent 1 is my guess for which is larger. That's awfully hard to estimate, and in cases like this we would probably use a calculator to figure out which one is larger. So that's it. Again, the topics that we were trying to learn mostly involve the 6 trig definitions. There are 4 spots on a circle that we know about right now. They're listed as 5 because 0 and 2 pi are the same thing, and we need to evaluate all 6 trig functions at both of those spots.